So the system has 2 UV lasers, 2 computers, 2 power supplies, and 2 chillers. It has an X slide in which you can put cylindrical objects, a rotary fixture option, and also an option where you can have fixtures for sequential marking along the X slide. This system has a power puck which is located right here. When an operator starts the system, the slide will move the power puck underneath laser 1. And laser 1 can fire on the power puck, and then the power of the laser gets reported to the custom Worldwide Laser user interface software. When this power measurement is done, the slide moves under laser 2, and again the power puck is fired on, and the power of the laser is again reported to the custom user interface. When finished, the laser slides all the way back here. The power positions are reported. The operator can then make a decision whether the power levels are correct or incorrect, and if they're correct, they can start laser operations. If they're incorrect, then laser operations won't start, and they can do the power measurement cycle again. These lasers could also be CO2 lasers for marking organic materials, or they could be YAG or fiber lasers for marking metal materials. These UV lasers are particularly suited for medical devices or implantable medical devices, as they transfer very little heat into the product. In this case, we're going to use a cylindrical fixture in station 3 to demonstrate the system. So we close the door and we're ready to start the system. The slide is going to go to its home position and then reset so that the motion system has proper location, and then we can start the actual cycle. There's a power puck attached to the slide. It's going to move under laser 1. The laser is going to fire on the power puck and measure the laser power. The laser power is going to be reported up here so the user can see what the laser power is, and then it's going to slide under laser 2 and measure, again using the power puck, the power on laser 2, and that also will be reported up here. The operator is now given an option: is that proper power reading or not? If not, they say no. The process takes place again. If it is proper, they can say yes, and then they have the option to start the lasing process. So they press cycle start. It's now detecting the part, and we can start the cycle. It says part detected in station 3. You could have parts in all 4 stations or parts in any one of the stations. So you say yes, and the cycle should start, and you see laser marking now on the rod. So the cylindrical object is being laser marked, and you can see the laser light in that process. If the E-stop is pressed at this point, all motion is stopped, the laser is shut off, the fans are shut off, the computers are shut off, so there's no chance of any danger or injury to the operator. Whatever happened to cause the operator to press the emergency stop, wrong part not being marked properly, whatever, can be fixed and verified, and the door can be closed, and then you go around and turn on power and recycle the system.